Hey there, my name is Carl Taves, and I want to talk to you about a problem I've been thinking about for a bit. So every year I support the photo book industry. I don't mean to, but they're around, and it turns out that photo books are beloved by in-laws and grandparents. So I make a photo book. Of course, photo books are actually big business. Everyone from Google Photos to Shutterfly to Snapfish to Walgreens all has a photo book business. It's expensive for me. Um, Now, in addition to putting photos together, actually, to do it well, I need to figure out some text that goes with the photos. Um, and of course, it's a bit challenging. You got to find something that's appropriate, that's snappy, that's warm, and it's a hard process. And so, what I thought about doing was finding a way to either automate or at least partially automate to assist the process. There's a common saying that a picture can capture 1,000 words, and what I've written is something that I think can at least turn the tables to a certain extent. So, how does it work? Here's the basic idea. I've written an app, which is basically a website, and you go find a photo that you like and capture its URL. Take that URL and stick it into my app, and say, find the poetry snippets. And now it is thinking, and I'm hoping that it will return something that is appropriate for the picture that we found, which is kind of a naturey, gardeny poem. And we'll see. And here it comes. So to blow this up a little bit, let's return to our slides, and I'll show you what the output is. So you can see that the picture is woods, grass, and the poem comes back with open grassy places, sunny, corresponding to the yellow of the leaves, there's earth. So clearly it captured the right spirit of the poem. It worked quite well. It actually works very well in other contexts as well. I encourage you to play with it at poeml.us. How does it work? Here's the basic pipeline. We start with photos from Flickr, pass them off to Google's Cloud Vision API to extract semantic information, stick that information in PostgreSQL database, and we do the same with poems and quotes. I scraped about 35,000 poems from the web and some quotes as well. Once I have all the information in the database, I extract it into vector space using a variety of techniques that I'll talk about, and then using an algorithm that combines thematic matching, semantic matching, and sentiment matching, I produce a poem. So the devil's in the details. The details are as follows. So I start things off by using the standard natural language processing techniques of eliminating stop words, lemmatizing, and tokenizing to reduce the language to sort of important nuggets. I then take those the language that remains and stick it into a continuous bag of words model. Not all words are created equal, and so to emphasize those that are important, I use a TF-IDF weighting scheme, and then a non-negative matrix factorization to divide those poems into topics, each of which is characterized by a couple of words. Those words I send off to continuous semantic vector space using word2vec. Take this geometric centroid, and that, of course, becomes my first topic vector. I do the same for all the topics. On the photo side, I'm using a convolutional neural network from Google's API to extract semantic information, mostly labels from photos. And these then get sent to a bag of words, which is similarly vectorized and gives me a photo. The match is then ultimately a regularized match between cosine similarity but penalized by differences in sentiment. Does it work? Well, it's hard to test, but I decided to focus on three classes of images: city images, nature images, and love images, and see whether or not they would get sent to similar poems. And within my test set, here is the results. You can see that the confusion matrix has most of the weight in the diagonal. It is not perfect, but I have about a 2/3 success rate. My name's Carl. I have a PhD in pure math. I worked for a couple of years in satellite modeling at the MIT Lincoln Lab, did a postdoc at the Institute for Math and Applications in Mathematical Imaging. And when I'm not extracting information from photos and poems, I am cooking, playing in the hills, or making music. Thanks for listening.